let's do this. Got a lot to cover today, so we're going to get right into it. Well, after some announcements. Just a reminder, I have the lecture channel open on Discord on my phone. If you see me staring at my phone and reading stuff, I'm probably answering questions. I'm probably reading questions, then I'll answer them. If you have questions, feel free to hit up the Discord lecture channel. We have TAs here today who will be able to answer your questions. If they can't, they'll flag me down. Or if I get to the question before they do, I'll be able to answer it during lecture. What's up, Tofu? And let's get to it. So today is the last day of content for task 1. Each task corresponds to a week of content. Today's the end of the first week already. We are ready for task 1. So let me introduce this and talk about what programming task 1 is. First, from the course website, you can collapse the syllabus. Hopefully you've all read the syllabus by now. You know everything that's in there. And then right above week 1, right at the top of each learning objective is where the projects will be posted. So pale blue dot posted right here on the course website. When you click that, you'll go to the Google Doc. It has some good information above this, but I just want to talk about task 1 during lecture time. Task 1, for this, each task in the course and application objective will have testing and functionality components. The testing is where you're going to write unit tests that are going to test your code and make sure that it's functional. Those tests will be graded in AutoLab based on their ability to distinguish between correct and incorrect solutions. We haven't talked about unit testing yet, so that doesn't make sense for task 1. So the unit tests are given to you for task 1. They're already in the repo, so that testing objective is already complete, all done. AutoLab will still grade your test just so you get used to what the feedback is going to look like in future tasks. In future tasks, that will actually be grading your assignment, your testing. That still exists for task 1 just to show you what that's going to look like. But all it's doing is grading the tests that I wrote. They should pass. Your testing should be fine. And then you'll go right to the functionality. The functionality, you're going to write a method called getCountryCode, which is going to take the name of a file containing country codes in this format with that on each line for different countries. You're going to be given the name of a country. So if you were given a string, United States of America, and this file, you would return the country code for that country, the 2-digit country code as lowercase letters. So United States of America, you would output US in lowercase letters for this method. So that's what we want you to be able to build. We got quite a bit going on here. We got reading a file, parsing the file, doing some string parsing, looping over the lines of the file, and returning the correct value that you're looping over. So we got quite a bit going on. It's all 115 concepts, but we're getting used to Scala. So we're taking quite a few 115 concepts, throwing them in one question, which isn't overwhelming. You can get this done in less than 10 lines of code since it's only the first task. So let's learn how to do that. Quite a bit of that you know how to do. Can I even say that? We really didn't cover much in one day. But let's figure out how to do the rest of that today. A lot of ground to cover. So let's cover that ground. Types, loops, strings, and reading files. It's a mouthful today. It's going to feel like a big potpourri of random topics today, just like Wednesday was. None of the topics are too complex. Again, we're still reviewing 115, but in Scala. But let's go through them. We will add a little bit to each concept. First, we're going to talk about types in Scala. So we mentioned the idea that Scala is strongly typed on Wednesday. You have to specify your types, especially for your method parameters and method return types. You have to explicitly say what those types are in order for Scala to work. Scala won't touch your code. It'll give you errors and say, hey, what are your types? On variables, other than parameters, you can get away with not specifying your types in certain cases. Scala will infer the types, but it's recommended that you have your types explicitly mentioned. But everything has a type. Every variable has a type in Scala. And to start, we'll look at these types, int, long, double, Boolean, unit, and string. So I want to go through these one at a time, just talk about what each one of these types are. Some of these are somewhat familiar from 115, though Python and JavaScript make you so you don't have to really think about your types too much. So we're going to think about them a little more and explain what these types are. Int, you'll see this a lot throughout the semester. Most tasks that deal with integer values will use int as opposed to the next one on the next slide, which is long. An int is a whole number. It has to be a whole number. It cannot have any decimal portion. Integers are represented by 32 bits. In Scala, at least, in different languages, ints might be 64. In Scala, they are 32-bit representations. 31 of those bits are to represent the number, and then 1 bit for the sign. So the range that an integer can store is -2 to the 31 to +2 to the 31 minus 1. That minus 1 goes on the positive side for specific reasons that we don't care about in 116. But this is the range for an int in Scala. If you go outside of that range, the value will either underflow or overflow based on which edge you go over. If you go under this -2.14 billion or above 2.14 billion, you either underflow or overflow, which means the number will effectively wrap around to the other side of this range. So you can run this code in Scala, declare a variable of type int, set it equal to this maximum value, and just add 1 to it. You add 1, you're not going to get just the next value. It's going to wrap all the way around to the most negative integer value. This will actually print out -2.14 billion, which is probably not the number you want if you're using this in your code. This probably isn't what you want to happen when you're using integer values. So whenever you're using an int, you got to be mindful of, am I going to go outside of this range? If you might potentially go outside that range, you probably don't want to use an int. For this class, on the homework assignments, depending on your approach, you might have an approach that uses something different, but you shouldn't run into this overflow with ints. So if a question says return an int or take an int, those ints probably won't overflow. But in your careers, this is something you will have to think about when it comes up. If that is a problem, long is usually a simple solution to this. Use a long. This is just like an int, except it uses 64 bits. 1 sign bit and 63 bits for the integer. So we can go from -2 to the 63 to +2 to the 63 minus 1. So we got a much, much bigger range. So if you expect to overflow an int or underflow an int, pull out your long, use longs, and this will give you a much wider range. If you want to overflow a long, if you're going to overflow a long, you got to rethink what type you're using and what you're doing in your code. Now with a long, we don't have that same overflow problem at 2.14 billion. We can add 1 to that, and everything's just fine. We'll see longs one time in the course. There is one specific case in the course where we will deal with values that will overflow an int. But that's something for me to worry about, not you necessarily. But this is how your values are working under the hood. Integer division is something you will have to worry about. If you have 2 ints or 2 longs or some mix, 1 int and 1 long, and you want to divide them, Scala will use what's called integer division. So if you want to divide 2 ints, the result will be an int, no matter what. Scala will use integer division, which means 2 ints divided by each other, which will return an int. Integers have to be whole numbers. So if there's some remainder or some decimal portion to your division, it will be erased. It won't exist in your solution. So if we have 245 divided by 12, which the answer would be 20.4, right? 20 with a remainder of 5. That won't be the case in this code. This will be integer division. the decimal portion is truncated. It's just erased. It's flat out erased, which is effectively taking the floor of the division, and you only get 20 out of this. This is something you need to be aware of. If you ever have two integers that you want to divide and preserve the decimal portion, make sure you're not just straight up dividing those two integers. There are ways to get around that. We'll see one example later in this lecture. But integer division is it's one of those things that can cause bugs that take a while to debug. I accidentally had integer division in one of my programs. It's a mistake you only really make once after you waste hours of your life trying to debug it and then realize integer division was truncating my decimal portions. Crap. If you do need a decimal portion, we're going to use doubles. Doubles are going to be they're numeric values, but you can have a decimal portion. You can have decimals. These don't have to be whole numbers. The representation, we'll save this for a later course. In 220, you'll learn all about this sign, exponent, fraction, how those 64 bits actually represent a double. In short, it's using scientific notation, but in binary. We don't have to worry about that too much in 116. But what we do have to worry about is that these are 64-bit representations. The important part about this being 64 bits is that 64 is less than infinity. This is a finite representation of a number, which means we are going to lose precision. When you're using a double, you won't necessarily have the exact value that you're trying to represent. And this is something we have to worry about in 116 extensively. I'll say this throughout the whole semester. Binary values, binary fractions, are represented very similar to decimal or base 10 fractions. If we have the value 0.11, this is saying 1/2, we have the halves place, plus 1/4, we have the 1/4 place, which is going to be 3/4. Very similar to if we had 0.11 in base 10, that would be 1/10 in the 10th place, and then 1/100th in the 100th place. Then add up your 1/10 plus 1/100th to get 11/100ths. We're doing the same thing, just in base 2. And that's very roughly how doubles work. That's how doubles are representing our values. In base 10, there are certain numbers that we just cannot represent using a finite amount of memory in this format, in decimal format. Obviously, right here, I represented this number exactly in finite memory. But in decimal representations, 1/3 cannot be represented. You have 0.3333 out to infinity. To get the exact number, you have to have an infinite number of 3s. You can never actually get the exact representation. Eventually, you just have to get sick of writing 3s and truncate the rest, which is going to be a rounded version of that number. The same exact thing is going to happen in base 2 in the computer. In our computers, if we try to represent, for example, base 0.1, 1/10 in base 10, we can't represent this as the sum of fractions of powers of 2. We can't represent it like we could represent 3/4 just fine. We cannot represent this value in base 2 exactly. In base 2, it's going to be this repeating 0, and then 0011, 0011, 0011. And it's going to repeat forever, just like our 3s repeated forever here. At some point, we're going to use up 64 bits, and we're going to have to stop writing 0011. At some point, we just have to stop. So the computer cannot represent, at least using doubles, these base 64 IEEE doubles, which Scala uses, we cannot represent 1/10. That value can't be represented exactly in your code, ever. It just can't happen. Instead, it's going to be truncated. And this is something we call a rounding error or a truncation error. And this is always something we have to think about when we're working with doubles. And this comes up even with fairly simple code. If we have 0.1, we know that B does not store the value 0.1. It's something very, 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 very close to 0.1, but it's not exact. It's truncated. It's got a little bit of error built into it. If you just print B to the screen, it's going to print 0.1, and you'll be none the wiser. It'll appear as though 0.1 is represented exactly. But once we start doing a little bit of math, I'm just going to times it by 3. In this code, this is Scala code. It's in the examples repo. You can run it right now. Multiply that thing by 3 and just print the result to the screen. And you're going to get something that's very, very close to 0.3, which is what you would expect. But it's not exactly 0.3. Now, for almost all cases, this is an acceptable error. It's off by so little that we're not going to run into too big of issues. There are cases where these errors can compound and actually give us the wrong answers in certain cases. But what we really have to be worried about in 116 is this. C equals 3 or 0.3 will be false. Effectively, they're equal. As humans, we'll treat them the same. That's basically 0.3. But if you have a conditional that says if C equal 0.3, that's false, and it's going to go into your else statement. It's going into your else condition. This will come up, especially when we talk about testing next Friday. And for lecture task 2, or not lecture tasks, we don't call them lecture tasks anymore. For task 2 of project 1, this will come up. This is something you do have to think about. You do have truncation errors with doubles. You have to be aware of those, especially when testing. When testing, you're checking if the output of the method was what you expected. If you're using equal to compare doubles, you're wrong. You can't do that because these truncation errors will catch up to you and give you the wrong results. Any questions so far? Like I said, we're just ripping through these types, so I want to talk a little bit about each one, then we'll get into loops and file reading. Question? Yeah, what's up?
So when we're programming, we're using base 10, right? The computer is analyzing it with binary.
Yes, exactly. So when you're coding, you'll always type 0.1 here. You'll always use base 10 when you're coding. But when that's actually stored in the hardware of the machine, the computer can only speak ones and zeros. That's all the computer can understand. So when the Scala takes this value, takes this string that you typed in your code, and represents it as a double in the machine, it's going to be in binary. It's not something, usually as programmers, it's not something we have to think about too much, but we do have to be aware of things like this, like doubles will have truncation errors because your base 10 values will be stored in binary. But you'll always type your code in base 10, at least in this class. Like you can type code in binary, but we don't like to, because it's, I don't know, humans we like to think in base 10. Thank you, Ululu. I did not notice that fell. Boolean and Unit. Boolean, I don't really have anything to talk about. True or false? For what it's worth, lowercase t, lowercase f. And then Unit, this is nothing. We use this as a return type for methods that don't return anything, methods that we call for purposes other than returning a value. For example, the main method, we don't want the main method to return anything. It doesn't really make sense for it to return anything. So the return type of the main method is unit. We don't call a program to have it return something to the operating system or to IntelliJ. It has a return type unit. Print line also, We don't call that for its return value. We call it to print something to the screen, and it returns unit. Just doesn't return anything. If you're comfortable with Java, this is the same as void in Java. Scala just decided to call it unit. I don't know why. I don't know why they had to change that, but they did, and that's what it is. It's called unit. And strings, the last type we'll talk about. It's a lot of types. A lot of types you should be fairly familiar with, though, again, Python and JavaScript didn't make you think about them too much. Scala, since you had to specify every type, you got to think, do I want this type to be an int or a double? Is it going to have a decimal portion or not? Is it going to overflow an int? Maybe it should be a long. You got to think about these things. JavaScript, you just have number is the only type, and you never even have to specify that type. Don't have to think about it. So the last one we'll talk about is string. String, again, you should be pretty familiar with. The string behaves very similarly in most languages. It's a sequence of characters. So we are using the char type as well, which is a single character, where a string is a sequence of characters, multiple characters stringed together. And we have quite a few methods that we can call on them. If you have a string, Python doesn't do that. In JavaScript, you can take that string and do .length and get the length, the number of characters in that string, for example. A helpful method for a variety of reasons. Starts with, you might find useful, does this string start with this other string? And what will be very useful in task 1 is split, and I'll show a few examples using .split. If you have a string, you can call .split and give it another string, and it'll return an array with the values of that string separated by the input that we call a delimiter. It'll be separated by those inputs, by those values, by the string, and it'll give you just the results with those values removed. So for example, in CSV in 1.15, we would say .split on commas, and then we'd get all the values between the commas in an array, and then we can do whatever we're supposed to do with those values, whatever we want to do with them. Oh, good, Priest is here. I was worried. Yeah, floats are 32-bit doubles. I won't use them in this course, but they do exist. Don't ask me why I like to use doubles but not longs. I don't have any reason other than those are the types that I was shown when I first started learning programming. There's a lot of things like that, which came up on Wednesday too. So let's take a look at some code. I won't go through this in too much detail. I think I only have one slide on this. But if you want to convert between these types, a lot of these common types, if there's a way to convert between them, you can do that by hitting them with the to and then the type that you want to convert them to. So for example, we have an int, a double, Boolean, and a string here. If we want to convert that string, a very useful one, especially on your homework starting with task 2, you want to convert a string to either a double or an int. You have a string, that string represents a number, and you want to get the number that that string represents. Just hit it with your to method, to double. This string is a well-formed double, so that's going to convert that string, parse it into 6.3 as a double. As long as there is a valid conversion, to double is going to make that conversion. For example, if this string said 6.3, like SIXPOINTTRHEE, if that was the string, you're going to get an error when you try to do that conversion to a double, because Scala doesn't know how to read that English and then convert that to a double. It just doesn't know how to do it. Since this is a well-formed double, 6.3, Scala will be able to convert that. Same with ints. If this were 63, just 6.3, then Scala will be able to convert it to an int. You'll be able to hit it with toInt, which it'll do for the populations in task 2. Get the population from the CSV file, .toInt, and that'll give you the population as an integer instead of as a string. toString, every value in Scala actually has a toString method. You can always call toString on anything and convert it to a string. So if you have some number, an int or a double or the Boolean even, just hit it with toString and it'll convert it to a string for you. If you just do a print statement, if you do print line in an integer, print line will implicitly call toString on that value because everything has a toString. And if you do conversions that don't 100% make sense, like a double to an int, sometimes you will get an output. In this case, you will get a value if you convert this double into an int. But it will truncate the decimal portion. It'll do the same thing as integer division, where whatever the decimal portion was, it's just going to delete it on you. So this 5.8, if you convert that double to an int, you're losing the 0.8 completely and just returning the 5, just the whole number point part of it. It will not round. So if that double was 4.999999999, it's giving you 4, not 5. It will not round. It will strictly truncate the decimal. So if you have some small truncation error in your double that subtracted a very insignificant small value from your double, which should be roughly a whole number, and then you convert it to an int, you might be completely off by 1. You might lose a whole number on that. So something to be careful of. Usually we don't like doing this and losing precision. So use that with caution if you're using it at all. All right, any questions on types? How are we feeling about all this? Yes?
So when you go from a double to an int, will it always round down?
Yes. Yeah, going from a double to an int always rounds down because it'll just delete the decimal portion. Whatever that whole number portion is, that's what it's keeping. All right. Let's talk about loops. So the structure for a loop, they behave very similar to the for each loops in Python or JavaScript. It's like doing for variable name of data structure in JavaScript, or in Python, in being the keyword there. In Scala, something you're going to see about Scala, you'll see this a lot on Monday and throughout the semester. The developers who wrote the Scala language love these arrows. They're all over the place. So instead of in or of, we have an arrow pointing to the left. So our structure for a for loop is for some variable name, less than dash some data structure. And that will iterate over all the values in that data structure, or more specifically, something that can be looped over. Doesn't necessarily have to be a data structure, but usually it will be. And then execute the body for each value. The way I like to remember this, well, now I just memorize it because I use it so much, but the data is coming from the data structure and going into your variable. So the arrow points from the data structure towards your variable. Taking data out of the data structure, putting in this variable, and then running the loop. So a few examples. If we want to do something similar in Python, you would use range to get a range of values to iterate over in your loop. We can do that same thing in Scala using the to method, which is actually a method that's part of the int class. We don't have to worry about the details. But we have for I, our standard looping variable, in the range 1 to n is going to iterate over those values inclusive of the endpoint. So this will include both 1 and n. So when we're calling this method with the value 10 for n, we're going to iterate from 1 to 10 and loop over all those values. If you don't want to include the endpoint, if you don't want to include n, you can use until instead of to. Can be handy later in the course. Or you can do to n minus 1. That'll get you the same thing. In most cases, we're iterating over a data structure. But in some rare instances, like on homework 3, way down the road, it will be helpful to use this to method or until to be able to iterate over integers like this that don't relate to a data structure. Just to show what's going on with this to method, this is a method that's going to return a data structure called a range, very similar to Python. Using Python's range, you get a range. This is going to return a data structure called range, which we can then iterate over. So this does the same thing as the other method. I'm just breaking it apart to show you the pieces of how this is working. We get a data structure for variable name in data structure, do this. So 1 to n, it's not magical syntax. It's kind of fun syntax, I guess. But it's syntax that calls a method, returns a data structure, and then we're iterating over that data structure. But usually we'll do it in one line like this. Go fall asleep, phone. Oh, come on. All right. Now let's do our first example that we'll spend some time on. This is the first example today that I'm going to break down. We're going to go line by line through this thing. So this program, admittedly pretty useless, strictly a lecture example, but we don't know enough quite yet to do something crazy until the homework. So we have a method. We have a method that's going to take in a string, which will be a string of Boolean values, or not necessarily Boolean values, but just true or false, separated by semicolons. And what I want to return is the percentage of those values that are true. So in this input, true, false, true, 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 80% of the values are true. So I expect compute percent true to return 0.8. So that's the behavior we want. I claim that this method does exactly that. So let's pick this apart and see how we're splitting a string. We're using our first string method, how we're iterating over those, and how we're avoiding integer division. So first, we're going to split the input string. We have our input string. We call the method. So line is going to be this string. And I want to split that on semicolons to be able to get all the individual values. And we're going to talk more in depth about data structures on Monday, but we do get to use our first one right here. Because how are we going to talk about loops without data structures? I guess range was our first one, technically. We're going to split that line on semicolons. Similar syntax as you should have seen in 115. And that's going to return an array of strings as its value. And we're going to store that in a value named splits. I'm never going to change that array, so I'm going to put it in a value. It's typically good practice, if you don't expect a value to change, to put it in a value instead of a var. I'll usually hold to that in my lecture examples and in just my regular coding too. So if you see val, I expect that to not change, and it won't change. So if I expect it to not change, one reason I like to do this, if I expect it not to change, I'm going to put it as a val. Then if it does accidentally change, if somehow it changes at some point, the compiler is going to yell at me and say, hey, you told me that wouldn't change, but now it's changing. And then I can look at that error and be like, whoa, that's not supposed to change. And then I can fix whatever I made, whatever mistake I made. That's one reason. Another reason is optimization. The compiler can optimize more if you have vals than vars because it knows it's never going to change. It can store that value differently. Okay, next I'm going to declare two variables, total count and true count. This is where I'm going to count the number of values that I've seen and the number of values that I've seen that are true. And I'm going to store those in doubles. I'll explain that in a second. I'm doing it to avoid integer division for a little foreshadow. But I'm going to store those as doubles, even though I expect them both to be integer values. They'll be whole numbers throughout the whole execution of this program. I have my array, my data structure of strings, and I want to loop over them. I want to handle each. These green boxes like to go in the foreground. I can't highlight my text like I like to. It's already in a box, though, so I guess I don't have to. So for some value is for some variable, which I happen to name value, I can name that whatever I want, just like your Python and JavaScript loops or whatever language you're coming from. For the values in this array, I want to execute the code of this loop. So for each one of the values, after we split on semicolons, so this is going to loop over true, in this program, true, then the string false, then the string true, then the string true, then the string true. So this loop is going to iterate 5 times over those values. So the first thing I'm going to do is convert that value to a Boolean. I can use my toBoolean method because I expect these to be well-formed Booleans. It's either going to be true or false as the string. So Scala is going to know how to convert those to Booleans for me. So I'm going to hit it with a toBoolean to get these in values that are Booleans. And then check, is this true? If this Boolean value is Boolean, that already is a Boolean, so it itself is a Boolean expression. Something you might be tempted to write, I see this a lot, and there's no problem with it, but it's unnecessary, is if value as Boolean equal true. Value as Boolean is already a Boolean, so it is itself a Boolean expression. I'm just going to say if value is Boolean. So if that's true, it's going to execute the body of that conditional, and if it's false, it won't. So if true, if I'm reading the value true, I want to increment my true count, how many times I've seen the value true, and whether it's true or not, I'm going to end the conditional. This isn't in an else. This executes every single time this loop iterates. I'm going to increment the total count, the total number of values that I've seen. And finally, I'm going to divide the two. This is always the last expression evaluated in this method. So this is the return value, is whatever this evaluates to. Now I have to be careful on this line to make sure I'm avoiding integer division. If we have integer division on this method, we will almost always be returning 0. So here we're going to have 4 divided by 5. If those are both integers, I'm going to get 0 with the remainder of 4. The remainder goes away, and I return 0. It would return 1 if and only if all the values are true. Then we could get like 5 divided by 5. It'll return 1. But otherwise, we're always going to return 0, which is not what we want out of this method. So we have to avoid that integer division. I'm doing that by just declaring doubles. There are a lot of other ways to handle this. You could declare these as integers, and then when you get to the division, do true count dot toDouble over total count dot toDouble. In fact, you only have to do it to one of them. If you have a double divided by an int, you'll get a double as a result. You won't have integer division. So I could do it that way. But whatever I do, I have to make sure I'm not dividing 2 ints at the end here, or I'm going to lose precision, and I'm going to get the wrong answer. If you divide 2 ints and get your 0 or 1, the return type is double, so Scala will still return a double, but it will execute the integer division first. It'll do the integer division, do the truncation, get rid of your decimal portion, and then after that, it's going to look at the return type and say, oh, I got an int and I need to return a double. And then Scala will convert that to a double for you. But it'll do that after the integer division. So something to be aware of when you're handling all that. So there's a lot going on in this method. I got to give a little bit of a disclaimer, I guess. This is pretty bad code. Like you probably wouldn't want to actually do this way. I am using this just so I can fit a lot of the topics that we're talking about in here. I got integer division, type conversions, looping over a data structure, a few different things here. There are a lot of different ways. I do have an alternate way to solve this, a much more compact, concise way of doing this in the repo if you want to check that out. This is specifically designed to show off a lot of concepts in lecture. Yeah?
Do we always call a function in the main?
No. So we do have to start in the main method. The question is, do we always call the function in the main? We do start in the main method. So in the main method, that's where we'll have to call some method. But for example, this method could call another method. I could have 8 methods defined here, and then have the methods all call each other. But to get the program to start, to get something to happen in the beginning, we need to start in the main method, and then call one of those methods, which might call another method, which might call another method. But the main method has to start the chain, or our unit tests, as we'll talk about next week, have to start the chain. You can't use Java fallback. No Java, no writing Java in this code, in this course. Assuming you mean write, yeah, Jesse, no Java. Assuming you mean writing Java, since it still compiles to Java bytecode just like Scala, that's a no-go. In Autolab, the very first thing I shouldn't say the very first thing, but one of the first things my Autolab script does when you make your submission is delete all files that don't end in .scala. And then I run the Scala compiler. So you got to write Scala. And I do that because of that. But. So in the previous example, we split a string on a delimiter, and then we iterated over all of the values in the resulting array. That's not always what you want. And in fact, in homework 1, that's never what you want. You never just want to iterate over all the values in a line. You have a line with a country name and country code separated by a hashtag. You want to split on the hashtag and get either the country name or the country code. You don't want a loop that's going to iterate over country name and country code. That doesn't make sense. It's not what you want in our cases. So if you want to get a specific value out of that string that's split, you can use parentheses to access them. These are usually brackets in a lot of languages. Parentheses in Scala, because these are actually method calls in Scala. Scala doesn't have any bracket notation for accessing values. So if you want the first value, your splits, whatever your result, your variable where you put the results of the split, that array. If you want the first value of an array, parentheses and a 0, second value, parentheses and a 1, third value, parentheses and a 2. So for task 1, you'll read your lines of the file one at a time, take the line, split it on the hashtag, and do splits of 0 if you want the country name, splits of 1 to get the country code. Which brings us to reading files. Man, there's so much in this lecture. So to read files, we're going to use Scala's built-in source object, one of the methods in this to read the files. And this is one of our first, is it the first, thing that we have to import. So import statements in Scala look like that. There's a package named scala.io. So there's a directory in the Scala standard library in that SDK that you downloaded. There's a directory Scala with a subdirectory IO with 2 files, buffered source and source.scala, or .class because it's probably compiled. So we want to import those. A lot of the standard stuff that we use, like string, array, those are auto-imported for us. We don't have to import them. If we want to use anything that's not auto-imported, we do have to have our explicit import statements. Lucky for us, IntelliJ is pretty good about managing these for us. That if you just start typing this code, IntelliJ will be like, oh, source, what's that? You want me to import it for you? I found one in the Scala library. And then you just click a button and say, yeah, and then it'll import it for you. So this is something we don't have to think about too much. Thankfully, modern-day IDEs are a fantastic thing. But we do have to get our imports in here because we're using something that's not auto-imported. The syntax for this, fairly straightforward. Source.fromFile, then give it the file name. You want to open a file, source.fromFile, file name as a string. It'll go look for a file with that name, and if it exists on your hard drive, it's going to open it up as a buffered source. We don't have to worry too much about what a buffered source is. There's only one thing we really have to worry about with that, is that buffered source has a method named getLines. Let me just go to the next slide that has it highlighted. Buffered source has a method named getLines, which is going to return to us a data structure containing all the lines of the file. We iterate over that data structure, And we effectively have a loop that's going to read the file one line at a time. This is something you did a lot in 115 in Python. This is how we do the same thing in Scala, just a little bit syntax difference. So open the file using source.fromFile, and then iterate over the lines using getLines to read each line of the file one at a time. Source.fromFile does not return a string. It returns the buffered source, which you can use to get the lines, which you use to iterate over the lines and get the lines as strings. So it's a way to access the file, the contents of the file. And then for this example, I'm doing something really silly. Don't do this, please. I see this in office hours all the time. Since cut and paste my example code and say, so this is how I do the homework, right? For the example code, I'm just doing something silly. I'm just appending all of the contents of the file into one big string. Don't do this. It doesn't help you on any of the homeworks. Just as you're reading through the lines, process the content as you're reading the lines. So for example, you're reading the country's lines one at a time. Inside your loop, split on hashtag, get your two values using splits of 0, splits of 1, or whatever you name your variable, and then do your logic to check if the input country name is on that line. If it is, grab your country code and be on your way. But just for example, I just did something to put something in that loop. It doesn't mean that's a wise thing to do to get all the contents in one string like this. So let's do this. Nicholas. Where can we find examples of these codes? If you go to the course website, one of the first links is a GitHub link, which has all of the code from the examples in lecture. So all the code that I showed in today's lecture, Wednesday's lecture, every lecture for the rest of the semester, except the rare cases where I make a mistake and forget that it's not in the repo. And forget to add it. It'll be in there. And lab, next week's lab document is posted on the course website. That walks you through cloning that repo and getting it inside your IntelliJ instead of going through the GitHub interface. So if you want to get ahead on that and start playing with this code, take a look at that lab document. Otherwise, you can wait for lab. But if your lab's after the early deadline for task 1, take that into consideration. Is there lab this week? You know what colon plus equals means? Nicholas.
Probably upend, but it's terrible. You shouldn't use it anyway.
It is. I know it's like those 3 characters, but I have to try a few times to get them in the right order because they don't make sense. I mean, it does, but it doesn't. It doesn't make intuitive sense. It only makes sense until you learn, once you learn what Scala is all about.
Yeah.
Oh, geez, we're only getting to the lecture question. I can't really.
Vision.
I can't get to my example in IntelliJ. Everyone good on the lecture question? Everybody still doing it? What's the answer? This one's there's a lot of content here. What's the answer? Yeah, you can all just shout it out. But.
Is it E?
E, yes. I heard a lot of E's in there. Good. The other 4 are true. These are all. There's a lot to highlight today, so these are 4 things that you need to take away from today's lecture. A lot of stuff there. After today's lecture, you do have everything you need to do task 1 on the homework, on project 1. At the start of Monday's lecture, I'll try to get to the example I want to show and show you how to set up task 1 if you're struggling with that. Other than that, have a great weekend. I'll see you Monday.